No, I intercepted 2. No, I intercepted 2.
Hey,
I
make sure
did
you have that
mistakes.
equation in there. I'm about to collect. I need you to have an equation in there.
I guess.
5, 4, 3, 2, and 1. All right. So let's look at our bell ringer. So first things first, did some of us forget some important details when it came to writing this equation? Nobody? No one forgot anything? Man, we are silent today. Come on. I know it's Tuesday or Wednesday today. It's not Tuesday. Today's Wednesday. Come on. What do we got? How are we supposed to know how to approach a problem like this? We got answers all over the place. Huh?
Noticing what's going on within the table.
So noticing what's going on within the table. I want you to remember that. The first thing is you got to know what type of function it is. What type of function are we dealing with?
Linear.
Linear. How do we know?
It's a table.
Table.
Are we just subtracting 5 every time?
No,
Minus 2.
we add 2 on the other side.
We want to notice that because if we were to look at every 1, it's actually going to be subtracting 2.5, not subtracting 5. But what makes this linear?
Table.
Say it one more time. The rate of change. If it is a linear, you got to be able to say, hey, the rate of change is what type? Not just additive. Not just repeated addition. There's another word that a lot of us are missing.
What does it start with?
A C.
Constant.
Constant additive. And the reason why I bring this up, okay, we're going to get into some other functions in a second. I know that you think I'm probably being crazy forcing that idea, but look, this right here, is this linear? No. But is there still an additive pattern?
Mm-hmm.
Yeah. If I look at the next one, I'm going to add how much? Minus 3, minus 1, plus 1, plus 3, plus 5. Plus how much?
7?
How'd you get that?
You going by odds.
Not just going by odds.
Pattern is plus 2.
Notice how these are each adding 2. So then the next one would be plus 9. So is there still an additive rate of change here?
Mm-hmm.
Is it constant though? Or is this the same thing every time?
Yes.
Is it the same thing? No.
Are we adding the same value right here every
No.
time? No. So is it constant? No. This is why it's important to recognize that, and so I probably should have clarified this in the past. When we say linear function has an additive rate of change, it's not just additive, it's constant additive, because there's other types of additive rates of change. Okay, we'll get into that starting early next week, what those other additive rates of change are. So we know it's linear function. Now I want you to remember, because this is a detail I'm seeing some of us forget, because it is a linear function, what equation should we be thinking about?
Because it's a
So notice the evidence is there's a constant additive rate of change, so it's linear. So what equation should we automatically be thinking about?
F of it. And then
Oh y'all, if we're talking about linear, we gotta know this equation right off the top of our heads.
Oh, fx plus mx plus b.
Plus mx plus b
Equals.
equals mx plus b. You gotta know that equation. As soon as you identify it's linear, we gotta know that equation. Right, so Destiny, what do we mean by m? The slope. Remember, what's the name of this equation? Slope intercept, right? So slope, but some of us are forgetting and just looking at the change in y values, but Omar, how do we calculate slope?
The rate of change?
That's how we define it, right? It is the rate of change for a line, right? It's a constant additive rate of change. But how do we calculate it? And that's a distinction that we need to notice.
Y2 minus Y1 divided by X2 minus X1, or rate of Y, I mean the change in Y over the change of X, or rise over line.
Notice there's 3 different ways to do it. I would recommend one of these 2 ways. You do what's good for you. Again, we got to know that slope formula, or a slope formula right off the top of our heads, okay? You got to know these things. I haven't given you graphic organizers back. I had to change lessons up based on where we got last night, so I had to change things and didn't have the time to finish grading. I'll get it back to you tomorrow. But we got to know this. These are details that we need to have on our graphic organizer so that we can study these moving forward. So we need to know this. Change in y divided by change in x, the rise divided by the run. You got to know that. Because, can you let Mitri in? When you remember this, is it just -5? No, Mr. Kitty. It's not just -5. Thanks, guys.
Over 2.
-5 what?
Over
Divided by 2.
Divided by 2. Thank you.
Sorry.
You're good. No, and so notice, like, y'all were struggling with this, and some of us are getting some of those details right, but -5 halves x, or -5 divided by 2x. Hold on 1 second. Okay? How many of us got -5 divided by 2? 1? We have one that's close down here with 5 halves. What's missing from this 5 halves though?
The negative.
The negative
And the x.
and the x. But I want y'all to notice, like, we are all over the place with our slope. We got to know how to do slope. It's been this since 8th grade math. It was this in Algebra 1, it's going to be this in Algebra 2. It's not going to change. You got to know how to calculate slope right away. By the way, I see a whole bunch of us staring up here, but a whole bunch of us got this wrong. So what could or should we be doing? Huh?
Taking notes.
Talking, taking notes, right? If you need to, because a lot of us are missing these bell ringers, I might suggest creating a bell ringer discussion notes page. We are missing too many of these, right? I know that we're getting back into a lot of these concepts, so we got to know how to do this. -5 halves is our slope. It's a linear function, it's a constant additive rate of change, and we got f of x equals -5 halves x plus, I heard someone say 17. Plus 17 for b?
Mm-hmm.
Okay? And I see a plus 17 up here for quite a few of these. But I also see a -5 or a 5 showing up here. I even see a +2. There's a few different options. So a lot of us said plus 17. Would someone care to tell us why they said maybe +2?
Because the on the table,
Yeah?
It's added.
the x is 0 and the y is 2.
So I can't just start at the top?
Well, you can, but
But what does that b stand for?
the y-intercept.
So is that 17 the y-intercept?
Yes.
No.
Yes.
That's where it starts.
It is where the table starts.
Where it breaks the y-axis.
How do you know that's where it's at on the y-axis?
No, it's 7. No, I don't know.
So
I ain't gonna know.
I want to point out, we need to pay attention to this. I think that was 10, 11,
How-
12.
always-
Okay, so I'm not going all the way to 17, but -4, 12 would be here. -2, 1, 2, 3, 4, 5, 6, 7 would be here. 0 to here. Whoops. And 2, -3 would be here. Tell me
2.
again, where's that y-intercept?
2.
2. When we have a table, what do we need in order to identify the y-intercept every time?
X and Y.
The x value is 0.
We need to have the x value of 0. I need you to write that down if you did not get that detail. The b, the y-intercept, the x value is always
0.
0. Thank you. We got to know that about y-intercepts. It's not just, hey, it's the first y value on the table. The y-intercept is only going to be when the x value is 0. You got to know the y-intercept is when the x value is 0. And so, should have been that 2 here. So -5 halves x plus 2. Okay. Thank you. Do you have a pass? We gotta know this, alright? Any questions about writing this equation? Nope, we good?
Mhm.
Do we need some more practice with writing equations like this?
Yes, sir.
Yeah.
Yeah? So bell ringers for that? Do we think we can master it through bell ringers, or do we need just a full practice day?
A full practice day.
Well,
Right.
it just depends on everybody. If they feel like they can come in here every day and do it as a bell ringer.
I know I ain't gonna be able to do it.
Hey, quick question, how many students do I teach right now? How many in here? 2, 5, 9, 10, 14, 16, 19. 19 students, how many people are responding?
2.
Come on, speak up, you got voices, use them. Advocate for yourself, right? I love that Anthony and Jakayla are super engaged, but Ishmael, you have an opinion, don't you?
Yeah.
Yeah? I'm hiding, Mr. King, you don't talk to me. Kyle, I know you got some opinions. I've heard you talking, having opinions for a long time, right?
What are you trying to say?
I'm just, you like to talk, all right. I understand it. So come on, guys, use your opinions or use your voices. By the way, Mitria, jump over here. I had Jenny move since no one else was here, so Allie will be joining in this group. Sound good? Okay. All right. We need to learn how to write equations. Some of us need to go back to our graphic organizers, go back to our notes. Especially number 5. Man, everyone's showing up late today. Jump in here to group 1 because I moved your group around. Your report card is back there though. Okay. Alright. What else was I about to say? I think that's it. Let's get started with today. As I already mentioned, I don't have your graphic organizers done because I had to, wait, did I put Gerald's over in this group? Or his report card?
He got it. His report card was like this.
so sad, dude.
Oh, it's got group 1.
I told you to sit in group 1, but,
And you said he was
I
going.
don't mind.
no, hold on a second.
I ain't know who you were.
Gerald, which group are you normally in?
I'll go though.
Okay, so you did get that one. Alright, jump over here to group 1 for me. Alright. So, one thing that I want to say is, I know that we are finally getting into like real math, and so, yikes. And so we are, some of us are shutting down on the concept of talking with each other, but you will learn and enjoy math class way more if you start talking with each other. I cannot emphasize that enough. The classes that I enjoyed the most and I learned the most were the ones where I discussed. And I can't force you to discuss, but I am going to score you on your active collaboration every single day. So I'm going to give you a reminder of that. I'm also going to hold off on the reminder about the scoring until I give you your graphic organizer back tomorrow. Hold on to your question. But I need you engaging. Yesterday was probably the quietest day that we had in class. And we need that, or I need that to stop. So we're then going to look at our objectives. We're going to wrap up a couple of quick details on lesson 1, which means we should already have out understanding concepts of linear functions. And then we're going to move to the lesson 2 that I passed out at the beginning of class. Who did not get a copy of this lesson 2 yet? Because, can you grab that floor for me? Because they showed up late. Demetria. Thank you. Kylie. Anybody else not get this understanding data in context because they were not here before the bell rang? Is that it? All right. So, again, I need, yes ma'am. You need one more?
Damn. I know they could have made it.
You need one as well? Do you have a copy?
Oh, for real, they got 89, 88.
Okay.
And my daddy said,
So you do have a copy of it?
No, I'm looking for it yet.
That's not what I asked.
I was gonna show you.
He just
these,
asked
though.
if I need a copy. I said yes.
I said, do you have a copy?
That's what I got.
Alright. So, couple of quick details. Again, not quick details. I need y'all to remember this. A lot of y'all need practice with writing equations and interpreting things and understanding slope. So you need to go to your notes. This is not something that you should be randomly looking at or just kind of blindly staring off into space, hoping it comes to you. You gotta know this. Yes, Jakayla.
Side note, when is this paper with the Matthew due?
I think it's on there, but it's on Sunday.
Okay.
That is a good question. Actually, really quick note. Did anybody try to get onto the Mathia stuff last night?
Not that night.
That homework assignment or daily practice assignment I gave you yesterday? No?
Mm.
Liam from my second vlog did try to get on, and he did email me saying that he was a little confused. Be aware, the directions to get into Clever are not where the assignment is. You have to then click on the Carnegie Learning app within Clever, and it'll take you there. So make sure you read the directions, follow it, because once I remind him of that, he was able to get there. I will be bringing in laptop carts tomorrow so that we can work on Carnegie Learning a little bit, but the amount of time we get to work on it depends on how far we get with this lesson 2 today, so we need to be working efficiently. So remember this, on the active collaboration, we want at a minimum a 3. I had some 0s through 2s starting to pop up. We need to be at a 3. In order to score a 3, what do you really have to do?
Do your work.
You gotta do your work. That's the main thing. You don't even have to talk to your small group really to earn a 3.
Does it have to be right?
What has to be right?
The work.
The work.
That's not a word, that's your active collaboration.
He
So-
said,
That's what I'm basically saying. Y'all
Oh,
gotta be right as long as we.
As long as you're working, it's a 3. Now, are you gonna learn a lot if it's not right?
Not much.
Not much. But that's why also, within a 3, you gotta be working, but then during the, whole class discussions, what are the 3 things that we should be thinking about with whole class discussions? Asking questions,
take a note.
taking notes, and sharing thoughts. Those are the 3 things. I'm gonna remind you of that. You gotta do those things. You gotta use your voice. And I need you to hear me very clearly on this. Yesterday was probably one of the quietest days during whole class discussion. If you don't talk, can you earn higher than a 3
Nope.
for the day?
Nope.
No,
You ain't gonna-
you can't. Because you can only take notes if you're not using your voice. You have to make sure you take the initiative. I'm not saying that you're talking the whole time. I'm saying that you say at least like 2 or 3 things. Get involved in the conversation. Ask questions. Share thoughts. You've got to do those things to learn. And that's just going to reflect in your grade. To be at a 4, you actually have to be engaging within your small group. You have to be talking and sharing your thoughts. You have to be listening to others' ideas and asking questions of each other. During the whole class discussions, you got to do how many of those 3 things?
All of them.
Not for a 4.
Oh, 3.
There are 3 things, but how many do you have to do?
2.
Usually does at least 2 of actively sharing thoughts, asking questions, or taking notes. You've got to use your voice in order to get to a 4. I cannot emphasize that enough. Too many of us are sitting there passively, and when we're sitting there passively and not sharing thoughts and not asking questions, then we're not learning as well as we can. You gotta stop being scared. I'm never gonna put a student down because of a question. I may sit there flustered for a second, like I just did, right? Because I was trying to figure out how to answer it, but that's not because I'm upset. It's just because I'm trying to figure out how to answer it, right? Or I might ask a question back to get you thinking more. I will never get upset about questions. Share your thoughts. It's okay to make mistakes as long as you are making mistakes and you're trying, because then we can correct those mistakes. Alright, in order to score to 5, you have to be showing leadership within your group for helping all learn, and during the whole class discussion, you have to be sharing thoughts, asking questions, and taking notes, all 3 of them. Now don't forget, it doesn't have to be the entire time. A 5, it's not 100% of the time, but it's very consistent. A 4, it's not 100% of the time, but it's at least 75% of the time. You gotta talk in order to learn and grow. I cannot emphasize that enough. Any questions?
Mm-mm.
We good?
Mm-mm.
Okay? Make sure you're actively collaborating, not just to score well, but those who are actively collaborating are going to learn the most. And also, get out your notes and use them, okay? I'm going to talk about the rubric tomorrow when I pass back your graphic organizers. We've heavily talked about identifying linear functions, and I think most of us identify that linear function in the bell ringer pretty well. We recognize those linear. We need to work on our language with it, but we still need to work on creating equations and translating among mathematical representations. So we're going to look at this number 8, because I think we finished up number 7 in class yesterday. Does that sound right? So we're going to finish up this number 8 before we move on to the next activity that we're working on. Huh? What? That's, it's lesson 1, understanding concepts of linear functions. That's what we worked on last Thursday and Friday, and yesterday. You should have had it from last Thursday.
Oh, that's,
Oh, we finished with 8.
No, get a sheet of paper, take notes, and then go from there. And make sure you transfer those notes over.
I wasn't.
Alright, with number 8, I'm not going to spend a ton of time here. Couple of quick details. 1, this lesson was only about understanding concepts of linear functions, right? But so you're given this equation, so it's a safe assumption that this equation is for what type of function?
Tell me.
This the old one. That's not the new one teacher gave us.
What type of
This old one.
function is this equation for?
Yeah.
Say it again.
Linear function? How do we know? Where do you see the additive rate of change?
The 2.
The 2.5?
the,
You think the 100?
no, the multiplication is being, what's the one?
Thank you. Right here. We need to remember that. This 2.5, even though it's second, that 2.5 is being what to the x? Multiplied. And fundamentally, multiplication is repeated addition. Thank you. Right? And Michaela, what kind of rate of change does a linear function have?
What was your question again?
What type of rate of change, so I'm letting Michaela think about it for a second, but what type of rate of change does a linear function have? One second. Do you remember? Okay. Anybody want to push back on that, or do we agree? Constant additive? Remember, constant repeated addition is shown through what? Multiplication, right? So I want you to remember, yes, we see multiplication here, but that's because if I repeatedly add, right, 3 plus 3 plus 3 plus 3, that's also the same as 3 times 4, right? Multiplication is repeated addition. So it's not a multiplicative rate of change. Does anyone remember what type of function does have a multiplicative rate of change?
Exponential.
Thank you. Remember that idea of an exponent is repeated multiplication. We can get into details on that on Friday. Okay? Does that make sense then, Michaela? We good with that? Alright, so the main thing I want to talk about here, I'm not going to get into the graph or get into a verbal description. I want us to notice is that there is a constant additive rate of change. By the way, what's the name of that constant additive rate of change? Slope, right? And what does m equal in this case?
Like,
You already said, right? That multiplication is my repeated addition. I'm repeatedly adding 2.5, right? We want to recognize that, which means the 100 is what? And so one thing I want to clarify, just because Ms. Courtney and I were talking about this last week, remember that 100 can't fully be the y-intercept. A y-intercept is a point. So how would I actually write the y-intercept? So the b is the y value of the y-intercept. That's one thing that we do want to clarify if we're being accurate with our language. The b is just the y value of the y-intercept. The y-intercept would be 0, 100. And that's how we're getting that equation. Do note that this is the alternative way to write slope-intercept form. Y'all are used to mx plus b. But, as Dawson pointed out, multiplication is repeated addition. That's really what's defining my slope. I appreciate those of y'all who are taking notes, making sure that you're getting these extra ideas down. good. Open the door for me, please. Last quick detail that I want to talk about. We already talked about the fact that the y-intercept is 100 and the x was 0, right? How many of us then did 1 and then 102.5? And 2 and 105? Yes, Michaela? Oh, you did that? Okay. I thought you were asking a question, my bad. Right? Anybody else do that?
Yes.
Yes? Okay. Quick question though, and this is just for the future. That's perfectly accurate, right? Notice we're adding 2.5 for every 1 in the x. Totally valid. But if the y-intercept is 100, and then you're adding by 2.5, is it really easy to get those same values on the axis? No. So what about this? Could I have done this? Just adding 25.
Yeah.
What would I need to do with my x in order to make that balance out correctly?
Go up by 5.
Yeah.
So let's check it. So that'd be 25 divided by 5, which is, notice that's change in y, change in x. That's what I'm getting at, that's 5. Is that the correct slope?
Oh, yeah.
What's the correct slope?
Oh, 2.5.
So is that the correct slope?
No.
So maybe not plus 5, but maybe plus 10?
Yeah. No. No, no.
25
I'm just talking.
divided by 10
Yeah,
would be what?
2.5.
2.5? Let's check it, right? You got calculators. Stop being scared to use your calculators to check yourself. 25 divided by 10, what do we get?
2.5.
It's 5 over 2.
5 divided by 2. Does anyone remember how we can get that into a decimal though? Control and then enter. Because remember, we're trying to compare that to 2.5. Some of us may already know that,
Oh,
but
there you go.
is it 2.5? Yeah.
Just talking.
All right, so then if I add another 10, but I want you to know this, can we guess and check?
Yes.
Yeah, could you have even done a different thing? Sure, right? I'm just pointing out that I might try to find something that works out nicely for the scaling. Right? Adding 10 to the x, adding 25 to the y. There's other ways to do it. So that's just something to consider. Notice if y-intercept is 100 and we're adding 25 to the y each time, will that make it easier to create that y-axis?
Yeah, but how can you change a 2.5 to 25? It'd still be right.
Well, because remember, slope is the change in y divided by the change in x, right? So it's originally 2.5 divided by 1. So to get to 25, anybody know what I did to 2.5 to get to 25?
Did you divide by,
I didn't divide, I multiplied by something. 2.5 times 10 is 25. Well, if I multiply the numerator by 10, so I don't change it, I gotta multiply the denominator by 10. No,
Wait,
10. Right? Isn't 25 divided by 10 the equivalent of 2.5?
I was just gonna say, so basically it's like it's equal to each other or something.
There are two numbers that are the same. You could also say they're equivalent. Those fractions look different. That fraction looks different than the decimal, but are they still the same?
Right.
Yeah.
That's how, right? Because has the slope changed? No. Do I still have the same y-intercept? Do I have the same slope? Yes. That's it. Does that make sense? Any questions? Make sure you get that note down. I'm gonna open up the file we need for today and then we'll get started. Nope, that's not there. If you have not already logged into the calculator, please make sure you do that now. Yeah, you should have gotten a file called linear modeling. That's what goes with understanding data in context. Yes, sir? Huh? Say it one more time.
All the papers I ain't got you.
Okay, you're asking me that 30 minutes in the class, right?
Then when I tried to raise my hand for a minute ago, you said, hold on,
We
question.
finna do
Okay,
an assignment.
but
That's why
I need you to ask me that before or after class. Remind me after class, okay?
We finna do an assignment, that's why I gave you a calculator.
By the way, you need a
That's why I
calculator.
told you to do it.
I'm about to explain it. Alright, so, objectives. Please note, we have several objectives with this. So, the first thing is calculator based. Also, I need you to pay attention to your objectives. It is hard to learn what you're supposed to learn if you don't know what you're supposed to learn. Right? So, if you want to, on this sheet of paper, you might want to jot down these quick ideas to help focus your attention later. But we want to use a calculator to identify an appropriate trend line to approximate data. Those are important words. I believe if you were here yesterday, you got a blue graphic organizer. Does that sound about right?
Yep.
Go look at that blue graphic organizer. You see any key words on there?
Trend line.
Trend lines. What else? By the way, who needs this graphic organizer? Because they were gone yesterday.
We could've did rate of, change too.
Say again?
We could've did the rate of changes.
Yes, for part of it.
Part of
Notice how it says focus on these three functions. So these three.
all days.
So you only know rate of change for linear. Some of us may know for exponential as well. Though. You never got this yet, right? Because we ended up not getting it. All right. Anybody else not have this blue sheet? All right. So which concepts are already within this objective up here?
Trend line.
Trend line.
I'm trying to see like linear function.
It just in number 1.
Oh. Yeah. Data on there.
Oh, data's on there too, right?
Yeah.
Okay. So what should you put under which lesson on this blue sheet? What's the name of this lesson?
Understanding data and
Understanding data and context, right? Remember, we should not be putting information down about these concepts in class, but you should be. Yes, ma'am.
I need a sheet.
The blue one? Okay. You should not be putting this, the concepts and different ideas down in class, but you should be identifying the lesson so you can come back and reflect on these later. There you go. Yes, ma'am. So please, make sure you pay attention to these objectives. There's 2 big ideas that we already know are going to come up, right? Also, as a quick note, in looking at y'all's graphic organizers that you've already turned in, a lot of us are just putting down pure definitions. When we create these graphic organizers, you might want to define things, but you also probably should give examples. You should also make connections, show how things go together, and also pay attention. I saw a lot of people tell me about properties of equality, and they wrote about the transitive and reflexive property, which are really good properties, but you know what I never talked about in class? Those 2 things. Stop Googling stuff. Use your notes.